it's a natural response or it's a natural question to ask. But
Hang on one second. If you're not talking, guys, can you please mute? I'm getting back feed from somebody. Sorry, go ahead.
No, can you go back to? Do you think you can go back and restate that again? Because my question would be, what is your argument that it's a natural question to ask this?
Hang on. All right, whoever has background noise, again, if you're not talking,
right.
Please mute your mic.
Yeah, Scott, Scotty, if that's you, please make sure you're muted. Once these two are done, you will be able to chime in again.
All right, so let's hope that works. So anyway, I'm sorry. So can you please repeat the question or the request?
Yeah, I think it'll be lost in. I'm not good at this. Yeah, I mean, I don't assume a force. I don't assume gravity. Things fall because they're heavy, and changing the medium doesn't alter that, unless, of course, the medium is more dense than the thing that's being dropped. So
okay, so objects fall just because. Okay, then let's go ahead and go with that. Then what?
No, not just because. It's not just because.
Then what is it?
They are heavy.
Okay, so objects fall because they are heavy. So if objects fall because they are heavy is your answer, then I can just as easily make a jump like that. That's very vague and very mysterious and doesn't answer a lot of questions. And say, okay, well, water sticks to a bowl because the water is lighter than the rock that's under it.
Say that one more time, please.
If you can
say that water sticks to a ball
because the rock underneath the water is heavier than the water itself. The earth is heavier than the water that's on it.
Sure. So that goes back to what I said before in my opening statement, that unless something of an explanation comports with my experience of my world, I'm not going to question it. So yeah, I've seen water hit a rock and find its level, and it flattens out and it finds its equilibrium as it spreads out until it can't spread out any farther because of surface tension or whatever it is.
Yeah,
however,
I've also seen water, over large bodies of water curve. I've also seen ships disappear over the horizon. I've seen the Chicago skyline, disappear depending on my altitude, especially at Warren Dunes, right across from Chicago. I have also seen in my own great state of Florida in Tampa Bay, objects disappear over the horizon, like what I filmed in, I believe it was October 3 years ago. And I also see buildings like, for example, the Apollo Power Station that's in Apollo Beach. The Tico Power Station that's in Apollo Beach. Half of that missing, 500 feet missing from viewpoint. Everything showing curvature. I also see curvature curving from left to right with the help of my DJI Mavic Pro when I went to 1,639 feet. I also see curvature thanks to Lake Pontchartrain Causeway observations done by Soundly. So you have not seen a water curve, but I sure as hell have. And thanks to the links down below, so can you. And you can go to all of these locations and do the observation yourself. Hell, I have 3 cameras that are perfect for the job, 2 P900s and a P1000. Join me at Lake Pontchartrain in December, and we can see it together.
Well, that would be interesting. When are you going?
The beginning of December. End of November, beginning of December. More like December 3rd to December 5th.
Okay, well, that would be interesting. I would be very intrigued to do that. I as well have a P900, but what I would say in terms of
mine's bigger than yours.
What you just, what I would say in terms of your examples that you gave is we are talking about the interpretation of the data. Okay, so again, I'm operating from the standpoint that water behaves in a uniform fashion. That is, that from any scale, beginning as small as you can, where you've got a container that has water, surface to surface, edge to edge, that water is flat. Okay?
Well, I disagree with that on a small scale. What about water drops? Water drops aren't flat.
No. I said, okay, if I didn't say it, I apologize, because I would assume that you know that I know that water droplets curve. Okay, that's not what
I'm
I'm
not going to
talking
assume
about. I'm
for you.
talking.
Apparently, that was
Okay,
an error I did previously. That's why I need you to clarify literally everything you say.
that's fine. Okay, that's fine. So I'm talking about water that is contained at any level, at any scale, from
Surface
edge to
tension
edge.
is a containment.
Okay, okay. When you say surface tension, can you describe just as briefly as possible what it is you're describing?
You're saying water at any level or any scale, I should say. Sorry. So basically, it doesn't matter if it's a puddle, a big tub of water, a small lake, the Gulf of
Right.
Mexico, or the entire Atlantic Ocean, that it's always going to be level. And here's the thing. Ignoring the water drops for a sec. So let's say a bigger scale. Let's say a
No,
dish
actually,
of
let's
water
not.
going forward. So going from there, I would agree with you that water is level. Where I disagree with you is that level automatically means flat, because I will agree with you. The Titanic, sank in perfectly level water. I will agree with you up, down, left, right, and center. What I disagree with you on is that if you were to see that Titanic sailing away, that it would conform to what we would expect to see on a flat Earth. We would see what we would expect to see on a round Earth, which is that ship disappearing bottom up and eventually out of sight, only to hit an iceberg halfway there.
Okay. Now, you've just changed the argument because you had brought up surface tension, and I wanted you to describe that, and you went on to changing your explanation. So can we go back to what I had said about water that is contained from edge to
Okay.
edge is going to be flat. Now, you took issue with that, so I was wanting you to just kind of describe what it was you were taking issue with in terms of a container, be it a teacup, a sink, a bathtub, what have you.
Okay, because here's the thing. You say the word container, okay? But what I think is that you're trying to make it seem like a container is just things that have walls. No, actually, the entire Earth, which is round, is also a container. And I don't think you would agree with that. So let's start there. If you're saying container, do you also include the Earth in that definition?
As long as you're talking about ponds and lakes that have confinement.
No, I'm talking about the entire ocean that you can sail all around the Earth. Because here's the thing, when I use the word container, I also put the entire Earth in there. If we were to assume that the entire Earth had no land and it was nothing but water, pretty fucked up scenario because we will all be dead, but still, I would say that Earth is still a container. What is containing the water? Well, it would be a thing that's holding the water to that surface in the first place. Gravity. Gravity acts as the walls, if you were, that hold the liquid in place. The walls of the container hold the liquid in place. I define a container as something that will hold the liquid in place. Do you extend that definition to the Earth itself? Because if not, then we're going to be arguing past each other.
Well, I think actually you're bringing up something that is irrelevant to the discussion, because the points that I brought up just a few minutes ago were teacups, sinks, bathtubs, and ponds, and that's where I stopped. So for you to extrapolate out and now waste a few minutes going off on your redefinition of a container, I'm not going to concede to that point. So let's try to stick to what I said, where I delineated what a container was and what I meant by it. I mean something that is confined by edges that holds water inside of it.
Okay, something that is defined by edges. Okay, so
Okay,
what about it?
really, a teacup, a sink, or a bathtub, or a swimming pool. I'm asking you simply because you took issue with the fact that I said that water is always flat, and then you talked about rain droplets, and then you made a point about a container. I was simply asking you to define what it was about a teacup that wouldn't fit into my my statement that the water in the teacup is level.
Yeah, water in the teacup is level. I think you misunderstood me, which is not surprising at this point,
I
because
thought you were going to make a point about surface tension.
I take no issue to you using the word level. What I take issue with is you equating the word level with the word flat. Because if we were to take your container example, one with walls, yes, if you were to have a small container, that water would be flat because the curvature would be too slight. It just wouldn't matter. The Earth is fucking massive. So in order to curve with the Earth, you need to have a container of sufficient size so that you can see the curvature in the first place. So if you had a container like, Lake Pontchartrain, for example, which is a lake which has edges, you will see the curvature of the Earth as linked in the description down below.
Okay, well, so here's what I'm going to say in terms of my empirical interpretation. Since I've never been to Lake Pontchartrain, I'm going to make a prediction. I predict that if you go on Google Maps and pick any 4 points on the shoreline of Lake Pontchartrain, they are all going to be the same altitude. Now, my interpretation of that is that we're talking about a flat Earth. It has that Lake Pontchartrain has boundaries, which we call the shoreline, and that shoreline is equal to each other point on the shoreline. It is all the same where it meets the water, where it meets the water, at least it's all the same altitude.
I'm not going to disagree with you there. I'm not going to disagree with you there because, yes, you can be on the same altitude as an altitude above the surface of a sphere. If I'm on one side of the sphere and I'm 5 feet off the surface of the sphere and I go to the other side of the sphere and I'm 5 feet off the surface of that side of the sphere, I'm still 5 feet off the surface. Just because you have the same altitude does not mean that the Earth is therefore flat.
Yes, it does, because you don't have anything else. Okay. You don't have, nor can you produce, any demonstrable observation of that except for the Earth, which you are presupposing to be spherical.
It's not a presupposition. It's actually demonstrated.
No, it's a presupposition, because if you do planar geometry, you're not going to get a curve. You're just not.
But the thing is that the other thing that planar geometry predicts is something that we don't actually see. And like I said in my original opening, when we modeled the observations with the assumed size and shape of the Earth, we actually matched what we got in reality. The observations done in reality match what is predicted by the round Earth model. Your planar geometry was also virtually modeled, and we went out into the real world to see if those observations could be replicated, and they could not. When you compare what your model predicts and what the round Earth model predicts, the round Earth model was on the correct side of the equal sign, not your guys's. So actually, no, It's not a presupposition. It's a conclusion based on empirical analysis of actual observations done by everyday people that you can do yourself. To disagree with that is to disagree with reality itself.
Okay, so let me just ask a point of clarification. You began this observation with planar geometry. Is that correct?
No, we didn't begin the observation with any sort of geometry. We began the observation by actually observing and seeing what happens. And then after we got the data points, we went and said, okay, let's go ahead and build 2 models. Let's build a model that's based on a flat Earth, and let's build a model that's based on the round Earth. Okay, we have a model of the flat Earth. Let's see if what we saw in reality matches up with that. Oh, look, it doesn't, to the surprise of literally nobody. Let's go ahead and see if this observation matches what we would expect to see on a round Earth. Oh, look, it matches perfectly. Of the 2 models being proposed then, the round Earth model is the one that was on the correct side of the equal sign. It successfully made a prediction, and that prediction turned out to be the case.
All right. Well, the difficulty then is